Now, continue to the next example. And the next example is, you're going to have to look at it a little bit like, twist around right here. So almost everything the same except like, something else. So the second example is asking you to find the linear approximations of the functions f of t that is equal to cosine of 2t at t equal to 1/2. And we want you to use the linear approximation to approximate the value of cosine of t, 2. So first, I need to find out what is the linearization function is going to be to do the linear approximation. So knowing that f of t, that is equal to cosine of 2t, taking derivatives respect to t, that will give me negative sine of 2t. And using the chain rule, taking derivative inside, that will give me 2. So therefore, I got negative 2 sine of 2t. To find out the linearization functions, I need to know the function value at half. So that is cosine of 2 times 1/2, which will give me cosine of 1. And then I need to know the slope of the tangent line at that point on the curve. So that is evaluating the derivative functions at half. So that will give me negative 2 times sine of 2 times half, which will give me negative 2 sine of 1. So now that I have information about the points on the curve and then also the slope of the tangent line at that particular point, now I can write down my linearization functions, which is L of x, that will be equal to f of 1/2 plus f prime of 1/2 times with x minus 1/2. Are we all okay with this? And which give us, this will be cosine of 1 minus 2 times sine of 1 times with x minus half. So that is our linearization function. So now what we want to do is we want to use this linearization function to do the linear approximations for the value of cosine of 2. So here's the questions. What is the value of cosine of 2? And here's the important part that you need to know, because I need to know exactly where my x is going to be. So you know what? I'm going to use this. I'm going to change this because every input right here is t, so I'm going to change with t right here on my linearization functions, okay? Otherwise, it will not be consistent anymore. So make sure you change that. So t right here, t, and then t minus 1. So now, cosine of 2, that is basically, we are talking about cosine of 2 times 1. And the reason why I write it like this is to help you to see that in the original function, f of t is equal to cosine of 2 times t. So how do I get cosine of 2? My t must be equal to 1. So that basically indicating cosine of 2, that is basically talking about we are evaluating f functions at 1. Okay? We are evaluating f functions at 1. So only if I know which input value that we are evaluating, then we can talk about the linear approximations. So now I can say that f of 1, that can be approximated with the linearization functions at 1. So this is the linear approximations. So therefore, now I can basically compute this by cosine of 1 minus 2 times sine of 1 times with 1 minus half. So which will give me approximately cosine of 1 minus, so 1 minus half is half. Half times 2 is 1, so it'll be minus sine of 1. And you may leave your answer like this, or if you use the calculator and approximate it, this will become negative 0.30116879, and so on and so forth, right? And that's basically help us to get the value. Now, what you want to do is you want to, use your calculator and then compute cosine of 2. See that this linearization's approximation is close enough or not. Right? And remember that this linearization function is formulated around t equal to half, and then we are evaluating at t equal to 1, so it's about like 0.5 away. Right? It's not that far, it's not that close, so there will be some error that we're going to have. And another thing that I want to point out is when you are computing this trigonometry function, make sure you are in a radian mode, right? Because these are not degree, otherwise you're going to mess up. So is there any questions before I move into the next topic?
The recording has stopped.
How did you get, after L equals T, how did you get equals cosine 1 minus 2 sine 1 times T minus 2? I don't understand how you got the cosine 1.
That is basically I'm substituting into this function. Because the linearization function is basically what? Cosine of 1 minus 2 sine of 1 times with t minus half. So when we are evaluating this, linearization function at 1, that basically cosine of 1 minus 2 sine of 1, but this time my t is 1, so it'll be 1 minus half. So I'm basically substituting into the linearization function that we found before we start doing approximation.
Okay.
Does that answer your questions? Is that clear?
Yeah.
Is there any other questions? Okay. If not, then let's continue.
I'm sorry.
Yes.
Hold on. So how did you get t to be 1 again?
How did I get t to be 1? Okay. So that's why you need to look at this step, right? To making sure and you understand that what is the value that we are trying to approximate? We want to approximate cosine of what? 2.
Yeah,
that's basically like, we need to ask the questions, hey, what do I need to plug in for t so that this cosine of 2t become cosine of 2? So by, in asking this question correctly, then you can see that must be 2 times 1. So therefore, this 1 is my what? T value that I need to substitute into the function. So that's how I interpret this cosine of 2 that is basically what? Evaluating the function at 1.
Yeah.
Got that?
Okay.
So make sure you write this step. I purposely write this step for you to see where this 1 is coming from, because my input must be 1, so that
So
cosine of.
If it would have said use a linear approximation to approximate the value of cosine of 4, then t would have been 2.
Exactly, in this case.
Okay.
But in this case, approximation of cosine of 4 will not be a good approximation using this, linearization function, because this linearization function is what? T equal to half, right?
Yeah.
And when to get cosine of 4, you are talking about t is what? 2 right there. that's too far apart.
Correct.
So you'll be getting like, you will get approximation, but it's not a good approximation. So we also need, why are we approximating it? It's because, when there are some functions, it's much harder to evaluate the actual functions. Then we want to use approximation to get some idea of the function value, right? And so we need to know what is a good approximation, what is not.
Okay, sounds good. Thank you.
Any other questions? Okay, all right. So now you can see that, these function values, can be evaluated at the particular points by this linearization functions. So now the next thing is we want to relate this into what is a differential, okay? And how the differential can work even a lot better and faster in some cases.